All right, y'all. So this lecture will be over support for college algebra section 2.3. So it's all about solving equations and interval notation and stuff. So the best thing to do is share my screen and let's work these problems. So first problem I got says solve using the addition principle. Now the addition principle says in order to get this x by itself, since this a is being added, I would subtract the a from both sides so that x equals my b minus a. Now, addition principle also works if you got something being subtracted. If it's being subtracted, I would add the a to both sides. So you do the opposite of what they got showing, okay? So then this would get me x equals b plus a. So that's the addition principle. And then all it says really is what you do to one side of the equation, you do to the other. What you do to one side of the equation, you do to the other. On each side of those equal signs, okay? So look, they got x plus 8 equals 32. All right, so we want to get the x by itself. So since they're adding 8, we want to subtract 8 from each side. Subtract 8 from the left side, do it from the right side of the equals so that this x comes down. Now you got 32 and you're adding a negative 8 to it, which is the same thing as 32 minus 8, which is 24. Now to check your answer, you would put the 24 back in for the x. So 24 plus 8, does that equal 32? Yes, 24 plus 8 is 32. So you get 32 equals 32, which is true. If your answers make that false, then you got to start over and find the right answer, okay? All right, so watch this one. They got negative 35 equals x minus 4. So they put the x on the right side with a number, and then on the left side is the number by itself. So the same thing, although the x is on the right side, I still want to get it by itself. So since this 4 is being subtracted from the x, if I add 4 to both sides, on the right side, you had an x, you bring it down. That negative 4 and positive 4, they cancel out. So the x is now by itself. And then over here, you got negative 35 and a positive 4. When you're adding unlike signs, you subtract the numbers. So 35 minus 4 is 31. And then you give this answer the same sign as the larger number. So my larger number was a negative 35. So I got to make that answer negative. So then you check that. Negative 35 equals negative 31 minus 4. And y'all, negative 31 minus 4 is a negative 35. All right, so the next one, I got a negative 1/3 plus a x equals a negative 5 over 24. So they want me to get the x by itself still. Now, had the variable had a fraction 2, I would do this problem totally different, but there's not a number in front of the variable. So they want me to, since that's a negative 1/3, I'm going to add a positive 1/3 to both sides. Now, what we got to realize is these cancel, bringing down your x. But y'all, I cannot add these fractions until I find a common denominator between the 3 and the 24. And the smallest number that 3 and 24 both go into is a 24. So the negative 5 over 24 will come over, and then we'll add that to this fraction once we change it into a 24 on the bottom. So you had a 3 on the bottom. To turn that into a 24, you have to multiply that by 8, which means to multiply the top by 8 also. Whatever you multiply the bottom by to change, you multiply the top, and 1 times 8 is 8. So now you got a common denominator, so that answer will be right here. Now, the bottom is a 24, so that's going to stay a 24 at the moment. Now we got to figure out what 8 and a -5 equal, because that's on the top. In an 8 and a -5, 8 minus 5 is 3. The larger number is positive, so the answer will be positive. So since I had unlike signs on these, I subtracted and gave the sign of the larger number. But y'all, guess what? 3 over 24 will reduce to a 1 over 8. So 3 divided by 3 was 1. 24 divided by 3 is 8. So always reduce those fractions and get that final answer, okay? All right, let's see. Now, starting at number 4, they want me to solve using the multiplication principle. So what that means is, if I got something like, A times X equals B, then to get to X by itself, I would divide both sides by A. So that the A's would cancel, I would bring down my X, and that would equal whatever B over A is. Also, the multiplication principle works if you got something like A being divided under the X, and that equal to a B. To get this X by itself, you would multiply both sides by the A. So what happens over here, your A's cancel and you get the X by itself, and then that equals B times A. Because you always want to get these X's to be a 1X, okay? So the thing about this is, if stuff is being multiplied, I divide to get those numbers moved. If stuff is being divided, I multiply to get that variable by itself. So you do the opposite of what they have shown, okay? So this one has -12y equals 48. So I want that to be a 1y. So to turn that into a 1y, I'm going to take -12 and divide by -12. And if I divide that left side by -12, I'm going to divide the right side by -12. So watch this. -12 divided by -12 makes that a 1y. And then 48 divided by -12, those are unlike signs. When you divide, it's going to make that a negative. And then 48 divided by 12 is 4. So I get a -4 for my answer. So -12 times -4 is a positive 48. All right, let's move on. So always check them answers just to be sure when you're done, okay? 5 has -x over 2 equals 10. Now, you can always treat the 10 like it's got a 1 on the bottom when you got fractions, but I don't worry about that on this, because what I'm going to do, since this x is being divided by a -2, now I'm going to keep the negative with the 2 on this one because I want my x to be positive when I'm done. So since this is basically being divided by -2, I'm going to multiply both sides by that -2. So I'm going to take this 10 and multiply it by -2. Remember, whoops, this was what? A -2 on the bottom. My bad, y'all. X on top, 2 on the bottom. I'm just keeping the negative here because when I multiply a negative times a negative, I'm going to get a positive x, okay? So watch this. The -2's cancel, making that a 1. So you got a 1x. And then over here, 10 times -2, you're multiplying unlike signs, so make that a negative. And then 10 times 2 is 20. So notice, if they're dividing, you multiply. And you got to multiply by a negative if your number is negative over here, okay? All right, 6 has a 4/5 x equal to a -1/10. So watch this. Since you got a 4/5 being multiplied by the x, you're going to divide by 4/5. But remember, when you divide fractions, we change it and flip the second number, right? So you're going to bring down that 4/5 x, and you're going to multiply by the reciprocal of 4/5, which is a 5/4. That's going to equal this -1/10 times 5/4. What I do to one side, I do to the other. Now watch this. These 5's cancel, making a 1. The 4's cancel, making a 1. 1 times 1 times x is x. Now I'm going to say, watch this. This one you can reduce before you multiply. If you reduce before you multiply, the 5 turns into a 1. The 10 turns into a 2. If you don't reduce it when you multiply, then you're going to have to reduce the final answer, okay? So if you didn't reduce, you would do -1 times 5 is -5. 10 times 4 is 40. Now you would have to reduce that answer to get my final answer, which is going to be a negative. 5 and 40 both divide by 5. So -5 divided by 5 makes the top a -1. 40 divided by 5 makes the bottom an 8. Now in MATLAB, it don't matter if you put the negative out front and then write the 1/8, or if you do the -1 on top, divide that by 8, it'll take all them answers, okay? Now watch this. If you'd have reduced it right here and made that a 1 and that a 2, when you multiply straight across, -1 times 1 is -1. 2 times 4 is 8. So a lot of times I do reduce before I multiply, but I wanted to show you that it worked both ways. All right, so next one wants me to solve using the multiplication and addition properties. So I got 4x minus 17 equals 7. So I'm going to use both properties, and usually you use the addition property first because you got to get the x's by themselves. So since that 17 is being subtracted, I'm going to add 17 to both sides. That's going to get this 4x by itself. So bring down that 4x. Those 17's cancel on that side. On the right side, I had to add that 17 to the 7 and make that a 24. Now I got 4 times x equals 24. Since they're multiplying that 4 times the x, we're going to divide both sides by 4. So let me divide 24 by 4. Watch this. 4 divided by 4 gives me 1x again. 24 divided by 4 gives me 6. So check this. 4 times 6 is 24. 24 minus 17 is 7. So they will work out if you check them answers. All right, y'all, this one I got 6x plus 12 equals -30. So first I'm going to move the 12, and then I'm going to figure out what to do with them x's. So since that 12 is being added, to move it, I need to subtract 12 from both sides. Right? That brings down my 6x. Those cancel. Now you're adding like signs. So since you're adding like signs, it's going to be a negative answer. Two negatives add to stay a negative answer. You can't make a positive out of these unless you're multiplying or dividing, okay? Now, since they're like signs, you add those numbers. So 30 plus 12 is 42, which means I get a -42 when I add those up. Now, since that's 6x and they're multiplying, I'm going to have to divide by my 6. So look here. 6 divided by 6 is 1, so I get a 1x. A negative divided by positive is a negative answer. And then 42 divided by 6 is 7. So my final answer is -7. 6 times -7 is -42. -42 plus 12 is a -30. So I really like how these answers all work once you start checking them. All right, y'all, number 9 is the trickiest of them all. So let's see what I got. I got 7/5 x plus 4/10 x equals 36 over 10. So this one can be done many ways. Now, the x's are like terms on this side. So in order for me to add these like terms, they got to have a common denominator. And the common denominator between 5 and 10 is 10. So I'm going to change both of these so they got a 10 on the bottom. That fraction already has a 10, so I'm going to leave it alone. This one, in order to make that bottom a 10, I had to multiply by 2, which means I'm going to multiply the top by 2. So watch what I get. 2 times 7 is 14 over 2 times 5 is 10x, plus I got a 4 over 10x. That's all going to equal a 36 over 10. Now these are like terms, so now I can add these x's together. So remember, the bottom at this moment is going to be 10, and the x is not changing. When you add variables, they do not change, only when you multiply. Now on top, 14 plus 4 is 18. So that gives me 18 over 10x. That's going to equal this side, which is 36 over 10. All right, so remember, we're focusing on the x. We're technically going to divide both sides by 18 over 10, but once again, we don't divide fractions, we multiply, and we're going to multiply by both sides by the reciprocal, which is a 10 over 18, 10 over 18. So watch these. These 10s cancel, making a 1. The 18s cancel, making a 1. So all that's left is your x. Now watch how quick I'm going to get done with this, because I want to reduce it before I multiply. I'm not going to simplify 36 times 10 over whatever 10 times 18 is. Watch that 10 and that 10. They cancel out, making a 1. And then watch this. 36 and 18. 36 divided by 18 is a 2. So that makes a 2 in a 1. So the top is 2 times 1, which is 2. The bottom is 1 times 1, which is 1. So y'all, since the bottom ended up being a 1, do I have to write that 1? No. So this answer would be x equals 2. Okay? So the trick is add these together, finding a common denominator. Once they're added together, multiply by the reciprocal of that fraction. Flip it, multiply both sides by the reciprocal, and then here reduce. Okay? All right, y'all, moving on. All right, number 10, they want me to write interval notation. So they're giving me x such that x is less than negative 2. So interval notation, we use parentheses if it's less than or greater than. We use brackets if it's less than or equal or greater than or equal. Infinity always uses parentheses, okay? So positive infinity or negative infinity use parentheses, okay? So they're saying here, x is less than negative 2. That means negative 2 is the biggest number. So since negative 2 is the biggest number, you always put the biggest number to the right side. Now, since that's less than, over here I said if it was less than, you use parentheses. So around the negative 2 will be a parentheses. Now we're going to put a comma here. Now, if you're less than negative 2, on your number line, you're headed toward the left. So here's negative 2. Then you get negative 3, negative 4, negative 5. We say if you're heading left on the number line, you're headed towards negative infinity. I can always get one number smaller by subtracting. So negative infinity would be to the left. So anytime you're less than a number, your negative infinity comes first, and then your number comes second. And remember, up here I said infinities always use parentheses. So this is now interval notation, and it means the same thing as x is less than negative 2. because my intercept goes from negative infinity up to -2. Now notice, since I didn't use these brackets, it don't equal -2, it's less than this -2. If that was a bracket, then it would actually equal that -2, okay? All right, y'all, number 11. Same thing, x such that, watch this, -4 is less than or equal to x is less than or equal to a +4. Now, since they gave me the two numbers on either side of the x, I don't get to use the infinities this time. So it's going to be the lowest number is going to be the -4. The biggest number will be the +4. But I got to figure out, do I want parentheses or brackets? Well, since the number to the left has equals, I put a bracket on it. Since the number to the right has the equals, I put a bracket on it. So they got equals, we use brackets. They got just the inequality without the equals, you use parentheses. All right, same thing here. So I got x such that -2 is greater than x, which is greater than -4. So what I would do if I was doing interval notation on this, it has to be in the right order, okay? -4 is the smallest number, so it's got to go first, and then the biggest number would be the -2. So y'all, the main thing is these got to go in the right order when you put them into interval notation. Now, at the -4, it's got no equals under it. So at -4, it's going to be curvy. At the -2, it don't have an equals. So it's going to be curvy. So -4 is less than x, which is what this is saying, because the x is bigger than the -4. And then x is less than my -2, which is what this is saying when it says -2 is greater than that x. Okay? So put them in order. They got to go in order from small number to the biggest number, which is what we call ascending order. You want to go small to large on these, okay? All right, y'all, let's see what I got coming in next. Now, 13, they're going to give you some graphs. So I got a graph here. Over here at -4, I got a curvy parenthesis. Over here at +2, I got a curvy parenthesis. And they're shading in between those, okay? And they just want me to write this in interval notation. Now, what I like about these problems is they're giving you the two endpoints, -4 on the left side, +2 on the right side. And if they're using curvy parentheses, we're going to use curvy parentheses. So they just basically want to understand, see that you understand that this graphical approach is the same thing as that interval notation, okay? Brackets, I mean, the ends are the same. All right, 14, they're giving me another line. So let's see. Over here at -6, I got a bracket. And y'all, this one just keeps going off to the right. So watch this. Since I got a bracket at my -6, and -6 is the smallest number, I'm going to put it in a bracket. Now, look at this. This thing keeps going to the right, and it does not stop. So since it's shaded to the right, this thing is off and trying to get to infinity. So remember, we put infinity. Infinity, we said, always has to use a curvy parenthesis. And that's just because there's no stopping point. It keeps going. I can keep adding one and keep adding one. So that's why we use the curves. Okay. So you notice on these problems, my answers pretty much look like what the brackets were they gave me, except for the infinity. Infinity always uses a curvy parenthesis. Let's see what I got here on 15. Solve and graph. So I got a plus 9 is less than or equal to a negative 12. So just like on equations, I want to get this a by itself. So since I got a 9 being added, we're going to subtract 9 from both sides. So watch this. The a comes down, the 9's cancel, and that's going to be less than or equal to. Remember, I got like signs, adding two negatives. That answer will be negative. And then 12 and 9 is 21. So then, um, let's see what I want to do. I got to write the answer in the thing. So you'll put this basically in the blank. Okay, you'll have the answer thing, A, such that, and then you put this answer in that said A is less than or equal to negative 21. Then they want you to graph this. So watch this. I'm going to draw my line. So say here's my negative 21 right here. So since A is less than or equal to negative 21 is the biggest number, so it's going to be with a bracket. And then less than shades to the left. Actually, this is pointing left, so you shade left. So anything that's shaded is going to be less than or equal to that negative 21. And y'all just remember, on a number line, any number to the left of another number is less than that number to the right. All right, let's see what we got next. Same thing on 16, solving graph, 7x greater than or equal to 49. So this 7 is being multiplied by the x. So to solve this, we're going to have to divide by the 7. So 7 divided by 7 is 1. So I get my x greater than or equal to 49 divided by 7 is 7. All right, so let's see that graph. So here would be my 7. So this says x is greater than or equal to 7. So at 7, I would have a bracket because of the equals. And then greater than shades to the right, right? Any number I shade will be greater than that 7. So that's headed off towards infinity. Also notice it pointed right, so I shaded right. All right, I'm going to do 17 right here. Now watch this one. I got negative 4x greater than or equal to a negative 2.8. All right, so decimals, if we want to, we're going to pop out the calculator for that. But watch this. Here's the important thing on this problem. I got a negative 4x, so I've got to divide both sides by that negative 4 because I want this to equal a positive 1. So check this out. Anytime you divide an inequality like this by a negative number, you got to reverse the direction of the inequality. Divide by negatives, flip that around. Greater than turns into less than, okay? Now, that gives me a 1x less than or equal to negative, watch this, negative 2.8 divided by negative 4. That should give me what, 70 cents or a 0.7. And it's positive because a negative divided by negative is a positive. Now that one, all they did was set builder notation. So they put the x such that, and then you pick the one with the less than or equals, because you got to flip it around, and then put in your 0.7. Okay, so they're not making me graph these last few on these. All right, 18, negative 3/8 x greater than or equal to a negative 1/16. All right, so remember, I would technically be dividing by negative 3/8, which means I'm going to flip and multiply both sides by a negative 8/3. But remember, since I'm technically dividing by a negative or multiplying by a negative, I've got to reverse that inequality and make it a less than or equal. And then take that negative 1/16 and multiply it by the negative 8 over 3. Okay? Because now negative times negative is going to make the x positive, and the 8's cancel, the 3's cancel, making a bunch of 1s. So that x is now less than or equal to negative times a negative. This answer will be positive. And I'm going to reduce, y'all, because 8 and 16 both have numbers. 8 divided by 8 is 1. 16 divided by 8 is 2. So now, negative times negative, 1 times 1 on top is 1 over 2 times 3 on the bottom is 6. All right, so the big thing on that, x such that x is less than or equal, because I divided by negative or multiply by negative, I got to reverse it. And then that was what, a 1, 6, close brackets. Now notice, up here, when I divided by a positive number, I do not reverse it. Only when I divided by these negative numbers, okay? All right, y'all, so I see one more to go. And then this one will be done. And this is number 19. 5y minus 2 is less than 7y minus 3. So I want all my y's on this side, numbers on that side. So I'm going to start out by moving the y's by subtracting 7y from both sides. So 5 minus 7 is a negative 2y, minus my 2 is less than that negative 3 because the y's canceled. Now we can get the negative 2y by itself by taking care of the number. Since that 2 subtracted, I would add 2 at this point and see what I get. So that negative 2y comes down. Those cancel. So this is less than negative 3 plus 2, unlike signs. So subtract. 3 minus 2 is 1. Larger number is negative, so the answer will be negative. So now negative 2y is less than negative 1. So now to make the negative 2y a 1y, we divide by that negative 2. So remember, since I'm dividing by a negative number, the less than now becomes a greater than. And then I do the same thing to that right side. So watch this. Negative 2 divided by negative 2 is a 1y greater than. Negative divided by negative makes that a positive. And then let's see, 1 divided by 2 will not reduce. So we get a positive 1/2. So here you go. X such, oh, that's a y. So y such that y is greater than 1/2. So this set builder notation, you just tell what the variable is. The bar means such that, and then you put your answer in here. MATLAB gives you it gives you like 4 choices by changing those. It'll put a less than equals, greater than equals. Just make sure you pick the right one for that, okay? All right, y'all, so that was your 2.3 support. So let me stop sharing my screen. And we're going to end this video, so y'all good luck.